Welcome to the class. Today we are going to learn an important topic from number system, which is LCM and HCF. So let's see what is the full form of LCM. LCM stands for least common multiple, and HCF stands for highest common factor. So in this class we are going to learn what is the basics of LCM and HCF, and what is the difference between them, and what are the different methods are there to solve LCM and HCF. So let's see the first concept. Let us see what is exactly LCM and HCF. If you see the question here, find the LCM HCF of 4 and 12. So we'll just do it manually. So first we will do LCM. What is the full form of LCM? Least common multiple. We should have a common multiple between 4 and 12, which should be least. We need to find out that, right? So what are the multiples of 4? 4 multiples are 4 ones are 4, 4 twos are 8, 3 is 12, 16, 20, 24, 28, 32, 36, and it will continue like this. And what are the multiples of 12? 12 ones are 12, 24, 36, 48, 60, and it will continue so on. Now here, what are the common multiples between 4 and 12? 12 is a common multiple, 24 is a common multiple, and 36. Like that we have so many common multiples between them. But what we need here, we need the least common multiple. So what is the least common multiple between 4 and 12? 12. So that is the meaning of LCM. Now let us see what is the HCF of 4 and 12. What is the full form of HCF? Highest common factor. Here we need to find out the common factor which is highest between 4 and 12. Okay. So what are the factors of 12? 1 is a factor of 4. Sorry. Here we are going to find the factors of 4 first. 1 is a factor of 4. 2 is a factor of 4. And 4 is a factor of 4. What is a factor? The number which divides this 4 exactly. That is known as factor, or we may call as divisor. So what are the factors of 12 now? 1, 2, 3 also divides 12, 4, 6 and 12. But if you see, there are common factors between 4 and 12 are 1, 2, 4, right? But I want highest. What is the highest between 4 and 12? Highest common factor? 4. So the HCF of 4 and 12 is 4. Now what is the LCM we got for 4 and 12? 12. And what is the HCF we got for 4 and 12? 4. Now remember one point here. HCF will divide LCM always. Exactly. So keep this point in mind. We'll see this concept later. Okay. Now let's move to the next concept. So now here we are going to find out how the LCM and HCF are done using prime factorization method. Okay. Let us see how to find out the LCM using prime factorization. We'll take some numbers here, 10, 15 and 20. So what is the prime factorization? Write the prime factors of this number. Means the product which you are writing for this number should be in the prime numbers. So 10 can be written in prime factors 2 into 5. 15 can be written as 3 into 5. And 20 can be written as 2 into 2 into 5. So this, it is written as 2 power 1 into 5 power 1, the degree, and here the degree is 3 power 1 into 5 power 1, and here it is 2 square into 5 power 1. So in prime factorization method, to find out LCM, we will multiply all the prime factors with highest degree. So for LCM, what we should do? I'll just write here, multiply all prime factors with highest degree. Okay. Now what are the prime factors we can see in these three numbers? You need to take every prime number we got here. 2 is there, 3 is there, and 5 is there. And we need to take highest degree. What is the highest degree of 2? You can see 2 square, and highest degree of 3 is 1, and 5 is 1. So we need to take the product of this. This will be the LCM. 4 3 is 12, and 12 into 5 it is 60. Okay. Now let us do HCF for the same numbers. What is the HCF of 10, 15, 20? Again, same in it concept. 10 is written as 2 power 1 into 5 power 1. 15 is written as 3 power 1 into 5 power 1. And 20 is written as 2 power 2 into 5 power 1. But when comes to HCF, we will multiply all the common factors with lowest degree. So remember this. In prime LCM, we will multiply all the prime factors, whether they are common or not, we will consider all, but they should be with highest degree. But in HCF, we will take only the common factors with lowest degree. What is the common factor in all the numbers here? 2 is not a common, 3 is also not common. What is the only value you can see in every product here? 5. And what is the lowest degree available? 5 power 1. So the HCF of 5, sorry, the HCF of 10, 15 and 20 is 5. Now let's see some more examples for prime factorization method. Now let us find out the LCM of 42, 70, 98 and 126 using prime factorization method. So how to write 42 in the products of prime numbers? 2 into 3 into 7. And what about 70? 2 into 5 into 7. What about 98? 2 into 7 into 7. And what about 126? 2 into 7 into 3 into 3. So here you can see it is 2 power 1, 3 power 1, 7 power 1, 2 power 1, 5 power 1, 7 power 1. This can be written as 2 power 1 into 7 square, and this can be written as 2 power 1 into 7 power 1 into 3 square. So now tell me the LCM of this. What is the LCM? We will take all the prime numbers. 2 is there, 3 is there, 5 is there, and 7 is there. But I will take highest degree. What is the highest degree of 2 available? That is 1 into. What is the highest degree of 3 available? Square. And here what is the highest degree of 5? 1. And what is the highest degree of 7? This is the LCM. What is the HCF? For the same numbers, we will take only common. If you see 2 is common in every number, so I will take 2, and 3 is not there, 5 is also not there. But if you see 7 is available in every number here, so I will take 7. But what I should consider? Lowest degree. So what is the lowest degree of 2? 2 power 1. And what is the lowest degree of 7? 7 power 1. So the HCF is 2 power 1 into 7 power 1, and the LCM is 2 power 1 into 3 square into 5 power 1 into 7 square. So this method is known as prime factorization method. Next, now we will see LCM and HCF using division method. So let us take one example here. Find out the LCM of 24 and 15 using division method. So how to do division method? 24, divide two numbers using prime factors. 2 12s, and it cannot be gone in 15. So now I can take 3, 4, 5, and next 2 times, 5 times. So continue this division until the remainder is a prime number of 1. Remainder means the leftover here. Okay. Now if you consider again, you can do it like this: 2 ones are 5 and 5 1 1. So what is the LCM? Take the product of this: 2 cube into 3 into 5. Now see how to do HCF of 24 and 15 using division method. In HCF, we will divide the largest number with smallest number. So 15 one time, 15, and the remainder is 9. Now take the divisor as new dividend and remainder as new divisor. So divisor 15. Now this remainder will be the new divisor. Now continue this until the remainder becomes 0. So at which place we got the remainder 0, at which divisor, that will be our HCF. So 9 one time, 9, 6. Again you need to bring this 9 here, and this remainder will become divisor now. So 6 ones are 6, remainder is 3. Next 6 will come here, 3 twos are 6. What is the remainder? 0. So at which place I got remainder 0, at which divisor? 3. So the HCF of 24 and 15 will be 3. So this is the method to do LCM and HCF using division method. Okay. Now let's move to the next slide. We'll see some examples how to find out the LCM and HCF using division method. Let us find out the LCM for 15, 30, 45 and 75. So doing division method. So all are multiples of 5, I think. 5 3 times, 6 times, 15 times, sorry, 5 9 times, and here it is 15. Now next, all are 3 multiples, continue with 3. 3 1 time, 2 times, 3 times, 5 times. Now if you see, all are either prime number or 1. So we can stop here. So what is the LCM? 2 into 3 square into 5 square. This will be the LCM of these numbers. Now let us see HCF using division method for the numbers 12, 18 and 24. So use division method to find out the HCF. Now if there are 3 numbers, select any 2 and continue the process. Largest number is 18, smallest is 12. 12 ones are 12 and the remainder is 6. And 12, 6 twos are 12, remainder is 0. So what is the HCF I got for 12 and 18? 6. Now do the process for 6 and 24. So 24, 6 times, 6 fours are 24, remainder is 0. So where I got the remainder 0 for all the 3? The divisor 6. So what is the HCF of 12, 18, 24? 6 is the HCF. Okay. Now let's see one more concept. Finding the HCF using difference concept. So whatever the methods I am explaining here, please try to learn all of them, because for some questions these particular methods can be useful, right? Okay. Now let's see difference method to find out HCF using difference method. So find out the HCF of 6 comma 9. So what is the difference between 6 and 9? 3. So here I'll tell you one point, just make a note of it and remember. HCF of any two numbers, let us consider A comma B, will be equal to any factor of B minus A, where B should be greater than A. Now what is the difference here? 3. So what are the factors of 3? 1 and 3. But I want highest common factor. So this is the HCF of 6 and 9. Understood? Now let's see one more example. Let us say find out the HCF of 10 and 15. What is the difference of 10 and 15? 5. So we have only two factors for 5. 1 and 5. So what is the greatest one? 5. So HCF of 10 and 15 is 5. Now let us see one more example. What is the HCF of 10 and 18? What is the difference between 10 and 18? 18 minus 10 is equal to 8. But here if you see, 8 will not divide 10 and 18 exactly. So what I need to consider? Factors. What are the factors of 8? 1 is a factor, 2 is a factor, 4 is a factor, and 8 is a factor of 8. So in these factors, which will divide 10 and 18 exactly? 8 will not divide, 4 will not divide, 2 will divide 10 and 18, and also 1 will divide. But what is the highest among these two? 2. So the HCF of 10 and 18 is 2. Next, last example. Find out the HCF of 93, 292, 496, 107, and 231. Let us say if you have these many numbers, pick the two numbers which are having least difference. So 93 and 107 are the numbers which are having least difference. So what is the difference between them? 14. What are the factors of 14? 14, 7, 2, and 1. But if you see here, in the series, there are odd numbers. So even number will not divide odd. So we can cancel 14 and 2. And 7 will not divide 93, because 93 is not a multiple of 7. So I can also delete 7. So what is the only thing we have left over? 1. So what is the HCF of these all numbers? 1 is the HCF. Okay. So this is the concept using difference method. Okay. So if you want, you can find out the HCF of these numbers also. 108, 126, 180, and 306. So what is the HCF of these numbers? What I told, select the numbers which are having least difference. So if you observe, 108 and 126 having less difference. So what is the difference between 108 and 126? 18. What are the factors of 18? 18 ones, 9 will be the factor, 6, 3, 2, 1. And what is the greatest number which will divide all these numbers? So 18 will divide 108 6 times, and 18 will divide 126 7 times, and here it will divide 10 times, and 18 will divide 306 also. Okay, so here 18 is dividing all the numbers, so no need to check the remaining one because this is the highest common factor which is dividing all of them. So what is the HCF of these numbers? 18. Okay, now we have one more concept called co-prime concept to find out the HCF, where it will be very helpful for us for some particular questions. We'll see that now. Now let's see how to find HCF using co-prime concept. Let us say we need to find the HCF of 50 and 60. Okay. Now 50 can be written as 10 into 5, and 60 can be written as 10 into 6, where we can call 10 as HCF when the other two numbers are in co-prime form. Actually, what is the co-prime? Co-prime set is the set of numbers whose HCF will be 1. Okay. Now, if you see here 5 and 6 HCF is 1. So that 5 and 6 are said to be in co-prime. Okay. Now, let's see one more example. We'll get a clarity. So 50 also can be written as 5 into 10, and 60 can be written as 5 into 12. Here I cannot take 5 as HCF because 10 and 12 are not co-primes. Because 10 and 12 HCF is not 1. 10 and 12 HCF is 2. So this I cannot consider this method, right? So what is the meaning here? Write down the number in the form of a common factor for the two numbers where the other two factors are in co-prime format. Okay, so let's see one more example here. Let us say we need to find out the HCF of 4 and 12. 4 can be written as 4 into 1, and 12 can be written as 4 into 3, where 1 and 3 are co-primes, and what is the HCF? 4. So in simple way, remember like this. Let us say there are two numbers. The numbers will be always in the form of HA comma HB, where H represents HCF and A comma B should be co-primes. If you see here, 4 can be written as 4 into 1, and 12 can be written as 4 into 3. So here A value is 1 and B value is 3. If it is ordered, we can take A value as 3 and B value as 1 also. Okay. So here from this I can also tell LCM will be equal to HAB, that is 4 into 1 into 3, which is equal to 12. So remember this concept, it will be very helpful for us. Okay, so we'll see one example problem on this. For example, so here the product of two numbers is given as 2028 and their HF is 13. How many such pairs of numbers can be formed? Okay. Now, what is the concept we have learned previously? HCF two numbers will be always in the form of HA comma HP. So what is the HCF given here? 13. So I can take the numbers as 13A and 13B. And what is the net product of these numbers given? 13A into 13B is equal to 2028. From this, AB is equal to 2028 by 13 into 13. So 113 we cancel one time, 72, 13 fives, and 78 will be the remainder. So it will be 6 times. Next, this 13 will cancel this 4 times. Now, what is the AB value I got? 12. So, what is this AB? We have seen that AB should be in which format? Coprimes. So, let's see how many coprimes can be formed using the value 12. That is a product we need to take. Okay. So, 12 can be written as coprimes format 1 and 12. A equal to 1 and B equal to 12. And what is the one more? I cannot take 2 and 6 because their HF is not 1. This is not work out. Can I take 3 and 4? Yes, I can take 3 and 4. So here, how many such pairs can be formed? 1 and 2. So what is the answer? 2 such pairs can be formed. Okay. So hope you have understood the concept of LCM and HCF. Suppose if we ask you to find out the numbers, just how many pairs are possible? 2 such pairs. So the numbers may be 13 into 1, 13 into 12, and 13 into 3, and 13 into 4. Okay. So this is the concept of LCM and HCF. Hope everyone understood this. So we have one more last small concept in this. So with this, we'll complete the concept of LCM and HCF. Let's move to that last one. So LCM and HCF of fractions. How to find out LCM and HCF of fractions? So we have a formula for that. LCM of fractions formula is LCM of numerators by HCF of denominators. Okay. Now what we need to do? Find out the LCM of 5, 3, and 1, and find out the HCF of 8, 4, and 2. So, what is the LCM of 5, 3 and 1? 15. And what is the HCF? So, our answer is 15 by 2. Now, let's see how to find out the HCF. What is the formula for HCF of fractions? HCF of fractions is equal to, now we will do HCF for numerators divided by LCM of denominators. Now, find out the HCF of 9, 12, 18 and 21, and find out the LCM of 10, 25, 35 and 40. Okay. What is the shortcut I told for to find out the HCF? Take any two numbers which is having a shortest distance. So if you see 9 and 12 are having a shortest difference. So 9 and 12, what is the difference? 3. So the HCF will be any factor of 3. So what are the factors of 3? Maybe 1, it may be 3. So 1 will divide all the numbers and 3 also will divide all the numbers. But I want highest. So what is the HCF? 3 is the HCF. Now, how to find out the LCM? LCM we can go for division method or we can write in the terms of prime factors. 10 can be written as 2 into 5 and 25 can be written as 5 into 5. 35 can be written as 5 into 7 and 40 can be written as 2 into 2 into 2 into 5. And what is the LCM? We need to take the all prime numbers product with highest degree. So 2 is there, but what is the highest degree of 2? 2 cube into. What is the highest degree of 5? 5 power 2. And what is the higher degree of 7? 1. So the LCM will be 2 cube into 5 square into 7. So it will be 2 cube is 8. 8 into 25, 200 and 200 into 7. It will be 1400. So this is our answer. So